No, 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 no. Marble countertops, marble boards, they are not cold. Sorry, I'm not yelling at you, I'm yelling at me. I'm the one who screwed up. See, I was on the internet and the algorithm served me one of my old videos the other day and I watched it, which was the first mistake that I made. The second mistake I made was that I said something really, really flatly wrong in that old video, which was from a while ago, therefore I suppose that was actually the first mistake. But anyways, it was an old video about pastry making, and the science mistake that I made in it is maybe the biggest science mistake that I've ever made in a video, which is saying something. I make a lot. Though usually they're small things and those don't bother me too much if I don't think about them too much. Like when I get a little detail wrong but the big idea or the practical takeaway is still correct, then I can kind of let myself off the hook. People in the top comments usually correct me on the little stuff, and that's something that I'm really grateful for, that we have a community that is self-correcting like that. But my God, did I get this marble and pastry thing wrong. And not only did I get the science wrong, but like the practical takeaway that I gave to you is like the polar opposite of what is actually true. Now, in my defense, it was just old-timey kitchen wisdom that I repeated. It's something that lots of people say. I didn't make it up. But in the opposite of my defense, I'm supposed to be the guy who doesn't just take the old-timey kitchen wisdom for granted. And I really, really fell down on the job, so let's fix it. Okay, to show you what I'm talking about, I'm gonna make some short crust pastry dough. It's 2-to-1 flour to butter by weight, and the butter needs to be cold, and that's relevant to what we're talking about today. Just cut the cold butter into the flour. You can do this with a food processor, you can do it with a fork or a knife, you can do it with a cutter tool like this. Just try to get that butter down into pieces so small that you can't really tell the butter from the flour anymore, and when you pick it up and squish it, it forms a little ball, a little bolus. I probably shouldn't use the word bolus to describe food that you haven't eaten yet. Then what you do is you put in just enough cold water to make it come together into a ball, just barely a ball. It will hydrate and solidify a bit as it cools sealed in the fridge, and you need to cool it sealed in the fridge so that the butter is nice and cold. And why does the butter need to be nice and cold? Well, because butter melts at room temperature, and as you work it at room temperature, if the butter melts, it'll flow in between all of those individual flour particles and it'll take you into a homogeneous mixture where there's butter and flour evenly spaced. And when that happens, it might not look any different as you're rolling it out, but when you bake it and then you bite into it, what's going to happen is it's going to be tough. It's going to be solid. What you want is like a heterogeneous texture, right? Where there's chunks of butter next to chunks of flour to create fault lines so that when you bake it and then bite into it, it flakes or crumbles. Anyway, the almost completely wrong kitchen wisdom that I uncritically parroted is that it's good to roll out pastry on marble surfaces or other stone surfaces like granite because they are cool and therefore they will keep your pastry cool, keep your butter from melting. Wow, that is wrong. Let's do a little experiment. Here's a little bit of marble, here's a little bit of wood. Take the surface temperature with an infrared thermometer, and they're both coming up about 22 Celsius, that's 71, 72 Fahrenheit, room temperature. Hardly surprising because they've been in my kitchen for a long time and therefore they've had time to come to equilibrium with their surroundings, thermal equilibrium. You would expect that. If I'd left this out in the sun, then it would be hot, but I left it in here and so it's the same temperature as the room. Not surprising. Put an ice cube onto each and get the old time lapse a-rolling. You're going to see about 20 minutes go by, and yeah, you can see the ice cube on the stone is melting much, much faster than the ice cube on the wood. Wow, what a big difference. That might as well be your pastry that's completely melted over there. Why does this happen? Well, let's look at the material. It's visually apparent the grain structure of this stone is so dense. There's just so much material here packed so tightly, atoms shoulder to atoms, and so many atoms. Look at the wood and you can see a completely different structure, right? Nice open grain structure. Wood comes from trees where it used to have water flowing through it. I mean, there's more water flowing through the outer sapwood than in the denser heartwood, but there's still channels for water all the way through this tree, and that creates open spaces, little open spaces in any product made out of wood. Let's see, what's this material over here? What is its porosity? I'm not sure if that's wood at all. Oh wait, no, that's a Grüns gummy. Grüns is the sponsor of this video. What is Grüns? Is it a multivitamin? No. Is it a greens gummy? No. Is it a probiotic? No. Is it a delicious snack? No. In fact, actually, yes. It's all of those things and more. As a daily supplement, I just eat one little packet every single day. There's 8 gummies. They're pectin-based, not gelatin-based, so they are vegan, they're dairy-free, nut-free, gluten-free, all that stuff. Particularly great for anybody who has trouble swallowing pills or doesn't want to deal with a powder-based drink that you have to chug. They're made with real vegetable and fruit, and they taste like it. I mean, there's nothing that's a chore about eating that. That is a tasty little treat. And they're loaded with antioxidants, potentially beneficial mushrooms, pretty much everything that I'm looking for in terms of a micronutrient supplement. And here's the thing. Look at the back. Got 100% of a lot of the vitamins and minerals that you can take a lot of that are safe to take in large doses. If you look down at the ones that you can potentially overdose on, there's 25% of your daily allowance, and that's really smart. I would be cautious about supplements that have 100 of everything or more than 100 of everything, because usually those are put together by people who either don't know what they're doing or they don't particularly care what they're doing. Grunes cares enough to give me something that I really enjoy eating. It's made with real sugar, so it digests easily, and there's only 70 calories, 3 added grams of sugar, but there's a sugar-free version if you want it. Hey, get yourself some Grunes. You can save 45% off right now with my link in the description. 45% off Grunes with my link in the description. Thank you, Grunes. Anyway, stone is generally more dense than wood, which is why it's heavier than wood. Just more atoms packed into a similar amount of physical space. And the most direct way that heat transfers from a hot place into a cool place is by a hot atom making contact with a cool atom and kind of rubbing on it to warm it up. Now, however thermally conductive a material is depends on a lot of factors beyond its density. It gets down to the particular electromagnetic properties of the molecules and elements involved, gets down to like the quantum level, but the easiest thing, and it's really determinative too, is just to understand the density thing. Here's a paper out of Portugal where they were looking at the thermal properties of different kinds of stone used in architecture, and here's this one particular limestone that they noticed had really high porosity, lots of teeny little holes of air inside that stone. And not surprisingly, when they tested its thermal conductivity with that gizmo there, let's see, which one is it? Yeah, that sample right there, by far the lowest thermal conductivity of all of them. Not a lot of pores, not a lot of insulating air inside of marble, which is why marble is cool to the touch. I'm touching this, it feels cold on my fingertips. Does that mean that it is cold? Well, it is cold relative to me, right? Like, I'm 98.6 degrees Fahrenheit. I'm a burning furnace like every other mammal. I'm hot, just like you. My kitchen is like 72 degrees Fahrenheit, which is warm by environmental standards, but relative to me, it's quite cool. So when I touch this thing that's at room temperature that also happens to be pretty thermally conductive, relatively speaking, what I feel is my heat leaving my body and transferring into the marble. You don't actually have a mechanism for feeling cold. What you feel when you feel cold is the heat leaving your body going somewhere else. So if the marble is warmer than the pastry, which it is because the pastry was in the fridge, then the marble is going to warm up the pastry, not cool it down. And it's going to do it faster than the wood because the marble is more thermally conductive. Now, that doesn't mean you can't use marble to cool things down. What if you're working with a really hot substance like molten chocolate? Molten chocolate is a lot hotter than room temperature, right? So in that case, the thermal conductivity of the stone is actually going to work to your advantage. You swirl around that chocolate that you're trying to cool down, it's going to transfer heat very quickly into the stone, and because the stone has a whole lot of heat capacity, that is to say it can take or absorb a lot of heat before it gets much warmer, just because there's so much of it, there's just a big bank there to fill up with heat, then it's going to stay nice and cool for a long time as you are working on that chocolate, which is awesome. Another thing that pastry chefs will do with marble slabs is that they'll throw them into the freezer, chill them down, and then work pastry on them. I wonder if that works. Here, let's take our marble and our wood, throw them in the freezer for a couple of hours, take them out again, and immediately put on a couple of ice cubes and then wait. It's taken a little longer this time. It's like 30 minutes, but that's funny. I think the wood is going to win anyway. Yeah, it's melting a little faster on the marble. It kind of surprises me because even though the stone and the wood started off at the same temperature, because the stone has so much more heat capacity, it can absorb so much more heat from the environment before actually raising in temperature, just because there's so much more of it. I figured the ice cube would melt slower on it, but I suppose the lack of conductivity on the wood wins out, and wood still seems to be the better choice for keeping something cold, at least when you're dealing with something about the mass of an ice cube. When you're dealing with larger masses, all of that math could change. And indeed, working with a larger marble slab could help, because if you chill that down, then bring it out again, just because there's more of it, it's going to take more heat from the environment and therefore more time to warm it up. Let's stack the deck a little bit. Let's just chill the marble and not the wood and repeat the experiment again. At this time, the marble definitely should win, and I don't think it is. I think the wood is winning all of these tests. So yeah, if you want to keep your pastry cold on room temperature surfaces, I'd go with wood or plastic. Poly has pretty similar thermal properties to wood in this context. That doesn't mean that all of the professionals who use marble are stupid. I mean, they use marble for all kinds of reasons. It's the nice smooth surface, it's pretty, it's really, really durable. Plus, you can send cooling elements either through it or underneath it. You know, jets of cold water that continuously stream through or under the material, wicking away the heat of whatever stuff you're working on top of the stone. That's what they do at the Cold Stone Creamery. That's why they call it that, and it makes total sense. You know, could they do that with wood? Could they send cooling elements through wood? No, because cool brings condensation. You'd get lots of water and microbial growth, and it just wouldn't make any sense. Stone or metal totally makes sense. Oh, plus the wood is less thermally conductive, and therefore it would do a worse job of taking the heat from the material and wicking it down into the cool water jets. Anyway, so that's the bit of totally bunk kitchen wisdom that I uncritically passed on to you, thus polluting your mind for years. I'm terribly sorry about that. I'll try to do better. Oh wait, I gotta tell you what I did with the pastry. So I had this nice rolled sheet of short crust pastry, and I figured I'll just root through the fridge and throw some stuff in there. It's some pre-grated cheese. Yes, pre-grated, but come on, it's just what's in the fridge. This is a really, really nice hard salami sliced. I've got some basil, just tossing it around in there, get it all mixed up, and then I'm just gonna fold in the edges. I could make that look prettier if I wanted to, but honestly, it's gonna look pretty as is. And you can brush it with egg wash if you want it to be shiny, but brushing it with water looks pretty nice too, and you don't have to waste a whole egg, and it'll make things stick to it. I need to put some salt on it. Nice crunchy smoked Malden sea salt, my favorite salt. I didn't season the pastry, so definitely gonna need some salt on here. Throw it in the oven, bake it at like 400 for about an hour until it's brown and solid, and there we go. It's a nice little midnight snack right there. As I was eating this, I was thinking, oh man, I should make savory galettes all the time. Fantastic way to get rid of leftovers in the refrigerator. And then I remembered how much butter is in this, and then I thought, well, savory galettes, terrific treat to have from time to time.